This video covers the basic concepts of reflection. So when a wave is traveling through one medium, it encounters a second medium, and some of the wave can be reflected. So you may have seen reflection before. Essentially, whenever you look into a mirror, visible light is reflecting off the mirror and back into your eyes. So whenever we discuss reflection, we have a few key terms that we will use. An interface is the boundary between two different objects, and the properties of the interface determine how the wave is reflected. A normal line is perpendicular to the interface, and we will use this to find the angles the waves are reflected. So let's assume that we have a wave coming into the interface, and we are going to call this the incident wave. The incident wave is a plane wave, so we can assume that the wave fronts look like this. The incident wave is then reflected off of the interface, and this is called the reflective wave, which is also a plane wave. And we call the angle between the incident wave and the normal line the incident angle, denoted theta sub I, and we call the angle between the normal line and the reflected wave the reflected angle, denoted theta sub R. If the interface is smooth like a mirror, the incident and reflected angle will be equal to one another. So let's do this example. A light strikes a mirror below. When the light leaves the mirror, what is the angle between the light and the mirror? So the first step is to always draw a normal line, which is perpendicular to the interface. Once this is drawn, we want to analyze the incident and reflected angle. The incident angle is the angle between the normal line and the incident wave, so therefore we have to calculate it. We know that the normal line is at a right angle to the interface, so we want to find out this unknown angle, and to do this we simply are going to do 90 minus 60. So we find out that the incident angle is 30 degrees. The light is then reflected like this, and we want to analyze the angles of the reflected angle. We know that the angle of incidence is going to equal the angle of reflection, so therefore we can say that this angle is also 30 degrees. Next, we want to look at the angle that hits the interface a second time. The normal and the interface are still at right angles, so we're going to know that this is going to be 60 degrees in order for this full angle to be equal to 90 degrees. Looking at this lower triangle, we know that this is at a right angle, and we still have this unknown angle at the bottom here, and once we do our calculation, since we know there's 180 degrees in a triangle, we can subtract 60 and 90, and we find that this unknown angle here is 30 degrees. Alrighty, so we're almost done. So next we draw a second normal line, and we know that the incident angle must be 60 degrees because this is at a right angle. So the light is reflected off the incident, off of the interface, and we know that the incident angle and the reflected angle are going to be the same, so this is going to be 60 degrees. So lastly, we can find that the angle between the light and the mirror off of the reflected wave is going to be 30 degrees.